let's look at some family of functions. We have x to the second power. This is the most basic quadratic equation. This function, if you recall, looks like a standard size parabola centered at 0, 0. Then, if you do the inverse of that, you would get something like this. But the problem is it wouldn't be called a function anymore if we drew the bottom part of the parabola. And the reason is because it doesn't pass the vertical line test. So what we have for the inverse function of x squared is the top half of our parabola turned over on its side. And that is the square root of x function. So x squared is a parabola, square root of x is like a parabola turned on its side, but you lose the bottom half because only the top half would make sense as a function. And also if you put in different numbers for x, you would never get anything in the negative area anyways. So that's what the square root of x function looks like. Then we have another pair that are similarly related, and these are inverse functions of each other, x cubed and the cube root of x. And the way x cubed looks is it kind of is like a steeper parabola in that little section, but then it twists down and goes down to the third quadrant going downward. And then when you flip this over and turn it, you end up getting the inverse of that function, which looks like this. And so what you want to keep in mind if you're not sure which way to draw the graph is there's some key points that are always involved. You have 0, 0 and 1, 1 in every single one of these graphs. 0, 0, 1, 1 will be included in these graphs. So if you're not sure if the curve should go above the line or below the line, make sure the curve always goes through 0, 0 and 1, 1, and then you can probably remember the general shape of it, and then you'll know where it should go. So the main thing I want you to notice is that x to the third and the cube root of x are inverse functions of one another. X squared and the square root of x are also inverse functions of each other. You may recall that we've done several of these before. This is a linear function. In its most basic form, we're talking y equals x. Then, once you put the absolute value on the x, it then bends this part up into a v, because absolute value can never be negative, and so your answer will never be negative down here. Then, the next two are the ones we just looked at, y equals x squared, y equals square root of x. Those look like what we drew before, and then y equals x cubed, and y equals the cube root of x. Now the reason I pulled this up is these are the 6 most common parent functions. These are parent functions because they're in their most standard position, they're very simple and clean, and we haven't made any transformations to them. The same transformations that we made to the 3 that we've done before, which are linear, absolute value functions, and quadratic functions, the same transformation rules apply to all the other functions, and really any function that you're going to deal with in Algebra 2. So we've got these 6 functions, and they could be shifted to the right, shifted to the left, they could be shifted up, they could be shifted down, they could be stretched vertically or compressed vertically, or they could be stretched horizontally or compressed horizontally. That almost looks the same as the vertical, but this one we're pushing it in from the horizontal direction, and this one we're stretching it in the vertical direction or compressing it in the vertical direction or flattening it. So you may recall all those things can happen, as well as we can have it reflected. So if it was up to begin with, we reflect it over the x-axis and then it goes down, or we could reflect something over the y-axis, so it would go this way. So those are all the transformations that we need to know. And so what's going to happen is you're going to do those transformations by thinking first of the parent function, and then you're going to do whatever transformation is necessary. The last thing I want you to notice on these 6 functions is that they all have something in common. They all go through 0, 0. They all go through 1, 1. And then the third point is different on each one. The first one goes through the point 2, 2. And then if you move down, this one goes through 0, 0, 1, 1, but its third point goes through 2, 4. And then the cube function, x to the third power, goes through 0, 0, 1, 1, but its third point goes through 2, 8. So you'll notice a pattern here. The linear one goes through 2, 2, the quadratic one goes through 2, 4, the cubic one goes through 2, 8. So 2, 4, 8. You're doubling the y value each time. That's just a quick way to remember it so that you can get your first 3 points every time on a parent function of these types. Now, what happens on the absolute value function is it also goes through 0, 0, 1, 1, and 2, 2. And the part that you have to remember is that it bends up and the left side makes a V rather than going straight on a line. Then, since the square function, or the quadratic function, x squared, and the square root function, square root of x, are inverse functions of each other, that means the third point on this one is 4, 2. It just switches the x and the y value. So notice, if you can see, 0, 0, 1, 1, and it goes through 4, 2. So those could be your first 3 points. So if you just memorize the 2, 2, 2, 4, 2, 8, just remember this one goes through 2, 2 as well, and this one goes through 4, 2. It's just switching its inverse, and you can imagine then that this one would go through 8, 2. And it does. It's at 0, 0, 1, 1, and then out at 8, 2. So you should be able to draw these 6 parent functions without a lot of thought in their original positions because of these patterns that I'm showing you. And just remember that the cubic one or the cube root one both do kind of an S figure. They kind of do a twist. And you already know that the x to the second power does a parabola. Just picture the parabola being turned on its side, and then you've pretty much got the square root function, except you have to drop off the bottom of the parabola because it wouldn't be a function anymore. And also because no matter if you take the square root of x, if x is positive, you're not going to ever get a negative y. So hopefully that helps remind you of the different parent functions and then introduces a couple of new parent functions. And then we'll get into the transformations that can happen. This is a sheet I made up. That's just an informal way of looking at function transformations. If you don't have access to this document, I would suggest screenshotting this slide and just read it over carefully and try to understand what numbers make what transformations. Let's just talk about it really quick. The function is considered to be between the brackets. So I consider inside the brackets inside the function, and outside the brackets is considered to be outside the function. The ones that are outside the function are y value changes, which means they're vertical changes, up and down of some sort. Then the ones inside the function are considered to be x value changes or horizontal changes, sideways. Things that are being added are shifts, where you just slide it. The one inside the function here is a left-right shift. The one outside the function is an up-down shift. Then you have the ones in front that are being multiplied, not added or subtracted, but multiplied. Those affect stretching and compressing. So the one inside the function makes a horizontal stretch or shrink or compression, sometimes it's called. And the one outside the function makes a vertical compression or stretch. Also keep in mind that if something is inside the function, everything inside the function, both here and here, kind of do the reverse of what you think they should do at face value. So in other words, if there's a number here that is a positive, it actually moves left, and if it's a negative, it actually moves right. If there's a number here, if it's something small like a fraction, like 1/3, you would think that that would compress it, but it actually horizontally stretches it. And then if the number here in front is something bigger than 1, like 3 or 4, it will actually shrink it or compress it horizontally. So that does, both of those things do the reverse of what you think. Whereas outside the function kind of goes in the direction that you would think it would go. So something at the end here, if it's positive, it'll go up. If it's negative, it'll go down, just like you would think it would. Then in the front, if it's a big number like 3 or 4, it's going to stretch it. It stretches it vertically. And if it's something small like 1/2 or 1/3 or 2/3 or something like that, it will actually compress it. It all depends if it's bigger than 1 or less than 1, whether it stretches or compresses. The last thing I want to point out is you also can look in the front and look for a negative. If there's a negative in the front, we're going to treat that as a separate transformation. You first do the stretch or the compression, but then you look at the negative, and the negative then flips it over. And it depends where it is. So all things inside the function are horizontal changes of some sort. So if you think of something flipping in a horizontal direction, that would be flipping sideways. That's actually flipping over the y-axis, but you can also just think of it as a horizontal flip. It's just flipping over sideways. And then the one in the front is a vertical change of some sort. And so I think that is a vertical flip or a vertical reflection. And so when you change something in a vertical motion, it goes from up to down or down to up. And so that would be a flip over the x-axis if it went from up to down or down to up. It'd be a flip over the x-axis. So mostly just think everything inside here is a horizontal change of some sort. Everything outside is a vertical change of some sort. So let's do a quick transformation. Here's the parent function. We're going to take it and do different transformations to it, starting from the inside out. This is a right 5 transformation, so every point will move to the right 5, and you'll look like this. Then you're going to stretch it vertically by a factor of 2. That just makes it taller. And then we're going to flip it over vertically, and so that puts it down here. And then we're going to add 3, which means up 3 in its position. So we're going to put everything up 3 from where it was before. And so it's going to look something like this. This is our final graph. If you plug this into the graphing calculator, it will be about in that position.